All right, now that we've looked at how to solve like exponential equations using logs, these real life problems that we get into, we're getting into much more real life things than just these normal typical problems you see, like how many watermelons does Johnny have? If Johnny has 50 and Susie has 13 watermelons, how many total watermelons do they have? Those whimsical, they're the word problems everybody makes fun of because you're like, well, that's not real life. Well, we're getting into stuff that actually is applicable to different fields of stuff you can actually see how it works. So I have another problem here. This is a little different. This is actually what we call logistic. And I'm not going to go too terribly much into logistic, but it's a good practice, good exercise in practicing and solving for a variable, regardless if it's in a numerator, denominator, or if it's just in a straight string. All right, so here it says the population of white-tailed deer in a wildlife refuge T months after their introduction to the refuge can be modeled by the logistic function n of t equals 480 divided by 1 plus 14 e to the negative 0.05 t. How many deer were initially introduced into the refuge? So from that model, I can actually tell you how many deer were initially put in there. How many months will it take until there are 63 deer in the refuge? I can do that as well. And then what is the maximum number of deer that can be in the refuge? Because there's going to be a maximum amount, because that just makes sense. It's not going to keep going forever and ever and ever, because eventually you run out of food. You run out of different things, water, things that the deer would need to survive off of. So you have what we call a carrying capacity, a maximum amount of deer that would live in that refuge. If you think of it on a bigger picture, there's only so many humans that can live on the earth because earth has a carrying capacity. What's the most amount of food and water the earth can provide for us to be able to sustain ourselves? So these, while we're looking at a very basic example, we can look at it at a much larger scale. Most diseases and everything else are logistic, not exponential growth. In fact, I will have you in class work a problem that me and Mr. Laver came up with showing logistic growth of COVID-19. So let's dive into this problem. All right, so the first problem was, how many deer were initially introduced into the refuge? So at that point, whenever they say initially introduced, that is time zero. That's when time starts ticking. When you put something in, that's when the time starts. It's not the actual time of day. It's that moment you put them in, that's time zero. So all I need to do is put 0 in here. Well, I know negative 0.5. Well, let me actually just plug it in. So we're going to do n of 0. This gives me 480 over 1 plus 14 e to the negative 0.5 times 0. Well, 0 times negative 0.5, that's 0. Any number to the 0 power, well, that's just 1. So this actually simplifies down to 480 over 1 plus 14, which is just nothing more than 480 divided by 15, which this actually equals, I don't know, what, 30? Where did I put my paper? Just use the calculator. 400, turn it on, 480 divided by 15, should be 30, 32. So initially, they introduced 32 deer to this refuge. So when we start at time 0, they put 32 deer into this refuge. That's what this model tells us. Now the next part of the question is, how long is it going to take when my deer, my n of t, is going to be 63? So how long is it going to take us to basically almost double this? From 32 deer to 63 deer. How long is that going to take? Well, what's nice about this is we don't actually have to solve for k. K was already given to us, but we are going to have to solve for t. So let's dive in and get this done. Okay, so we now need to know how long is it going to take to have 63 deer. So what I'm going to do is I'm going to put 63, because I want a total of 63 deer, equals 480 over 1 plus 14 e to the negative 0.5 t, and we just simply need to solve. Well, you learn in middle school that you're allowed to cross multiply across an equal sign, so that's what I'm going to do, is I'm going to get 63 times 1 plus 14 e to the negative 0.5 t equals 480. I'm now going to divide both sides by 63, and I've got 1 plus 14e to the negative 0.5t equals 480 divided by 63. I'm not even looking to reduce because I know I'm going to have to put this in a calculator, and a calculator doesn't care if it's reduced or not. So I'm just going to keep doing everything as I'm going to get t by itself before I even try to do anything. All right, so from here, I'm going to go ahead and subtract 1. So I've got 14e to the negative 0.5t equals 480 over 63 minus 1. Divide by 14, I've got e to the negative 0.5t equals 480 over 63 minus 1 over 14. We probably should clean this up so it's a little easier to put in the calculator. When I do clean this up, I'm going to get e to the negative 0.5 t equals, this cleans up to 1. I get 139 over 294. So it'll be a little easier to put in the calculator. So now I ln both sides. So we have negative 0.5t equals ln of 139 divided by 294. I'm off my screen. Just barely not. Now I divide this, so I have t. So let's put a little line here so you can see where I'm working at. So t equals ln of 139 over 294 divided by negative 0.5. When you throw it in your handy dandy calculator, t is going to be approximately 15 months. So it's going to take a little bit over a year, 1 year and 3 months, to basically go from 32 deer to 63 deer in the refuge. All right, so let's see what the maximum amount of deer this refuge can handle. All right, so what I'm going to do is I'm actually going to plug infinity in. So when time is really like way out in the near future, how many, not even the near future, way out in the future, how many deer can this refuge hold? Well, I'm going to do n of infinity. So I'm going to plug infinity for t. I got 480 over 1 plus 14e to the negative 0.5 times infinity. All right, so negative 0.5 times infinity, well, that's negative infinity. It's easy enough. It's easy enough. Because a negative times a positive is a negative. So now I have 480 over 1 plus 14e to the negative infinity. All right, so I'm going to use some exponent rules, and we're going to do, this is more of a thought than a calculation. So we're going to do 480 over 1 plus, now this negative exponent means this is in my denominator. So I have 14 over e to the infinite power. Well, e to the infinite power is infinity. So I have 480 over 1 plus 14 to infinity. So if I have a number over a really big number, just a small, this 14 is really a small number in the big picture of things. So 14 over a really giant number. What number is that really close to, but it's not actually it? Well, the number it's really close to is actually 0. We're going to treat this like it's 0. And we're going to get 480 divided by 1, which means at the most deer that could ever at one time be in the refuge would be 480 deer. That is the most. This is actually what's called the carrying capacity of your top number. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.